great pleasure to invite all of you to one more session on the professionalism in civil engineering. And we have the doyen of civil engineering here today to talk to us the past, present, and future of our profession. And before we request Professor Tandon to speak, I would like Mr. Girish to give some background and also welcome everyone on behalf of this series.
Thank you, Dr. Kalgal. I hope I am audible and visible as well.
Yes, you are visible also.
Thank you. Ellarigu namaskara, Shubhamanjane, good evening to one and all. On behalf of the Association of Consulting Civil Engineers India, I, HR Girish, extend a very warm welcome to each one of you to this popular series. As you all might be well aware that these webinar series are dedicated to the cause of enhancing professionalism in civil engineering and addressing those long pending topics such as the engineer's bill and as well as the other pertinent subjects which have become a bane from not having been executed so far. This webinar series is curated and hosted by the Association of Consulting Civil Engineers India and features every Saturday from 4:30 p.m. to 6:30 p.m. Indian Standard Time. It's in an online format through webinars so that we can facilitate as many people to attend and draw the benefits from thereon. So far, we have heard lectures and views of stalwarts and professionals from the construction and the civil engineering industry on series on various many aspects converging under the concept of professionalism and enhancing further in the domain of civil engineering. Today, every profession, more so the civil engineering profession, is at a crossroads of change. Change because of not only drastic technological development, but also revolutionary reforms coming up, as well as challenges faced by our society. And for these challenges, we, the professionals from the civil engineering fraternity, need to raise to the occasion and address their concerns, address their needs and wants, and provide the best-in-class solutions. Arrival of the pandemic, an unforeseen and unheard of situation, has only upped the challenge. The challenge is further compounded by man-made follies, or what should I say, man-made foolishness and greed, wherein instead of collaborating and complementing each other's skill sets, certain profession from the field of aesthetics has unfortunately embarked on an unfortunate adventure of usurping the rights which rightly, logically, and legally belong to those of the civil engineering professionals. And as a further to their folly, they have been trying to bring in an amendment to their act wherein the civil engineering professionals, they dream of bringing under their gamut of management and control. I would say that's a far cry which will never happen. In addition, we have exemplary body of knowledge and advisory mechanism in the form of the National Building Code provisions. In fact, these are the best in the world provisions, amongst the best provisions in the world, wherein these have been put together by decades of experiences of stalwarts from the industry. They also constitute bylaws, and you can say they are almost off-the-shelf solutions to a lot of challenges facing the construction industry in our nation. But unfortunately, the NBC provisions are more advisory in nature and not obligatory, thereby really putting more challenges to the extent of making the buildings dangerous by not complying with the bylaws and professionalism which are suggested in the National Building Code. Drawing back to today's talk, we have yet another legendary professional in Professor Mahesh Tandon with decades of experience and tons of wisdom, who is going to share his views and perhaps guide us on the path ahead. The format of today's talk will be as follows. Introduction of the speaker by Dr. Manmohan Kalgal, and then the speaker sharing his views, followed by a brief snippet from Ultratech Concrete on high flow concrete. And then that will be followed by the question and answer session and followed by the conclusion. So that will be the format of today's webinar, more so normal like every webinar series that we have been having. Now for the introduction of the speaker, may I request Dr. Manmohan Kalgal to introduce the erudite speaker to all of us. Over to you, Dr. Kalgal.
Thank you, Girish. Thank you, Girish, for giving the background in a very, very nice manner. and it gives me great pleasure to introduce Professor Mahesh Tandon to maybe one or two who might not be knowing about him. I think the entire fraternity knows Mahesh Tandon very intimately, but as the formality demands, I would like to introduce him formally. So Professor Mahesh Tandon, he's been in this profession for a very, very long time, and he's considered as one of the Bhishma Pitamahas of, structural engineering in particular and civil engineering in general. So he is presently the managing director of Tandon Consultants Private Limited. He's an international expert in the field of structural engineering, and many structures designed by Professor Tandon and Tandon Consultants have widely been acclaimed and have received recognition in India as well as internationally. He has spearheaded the development of new codes of practice and path-taking bridge technologies suited to Indian conditions. These include pioneering work in the field of segmental construction, integral construction, accelerated bridge construction, long span bridges, structures for metro, that is viaducts and underground. All of these are have made their own mark, and these have been described by the fraternity as highly creative, futuristic, aesthetic, environmentally sensitive, and innovative. Well, he has accreditation, International PE India, and he is a fellow of the National Academy of Engineering, FNAE. So that's a great honor, and he's been appointed as chairman of Research Council of the Central Building Research Institute as well. And he is the recipient of the Distinguished Alumnus Award of his alma mater, IIT Roorkee, in 2018. So under the AICT program, INE had appointed him as distinguished visiting professor to the various IITs at Kanpur, Roorkee, Gandhinagar, etc. Between 2005 and 15, and currently also is continuing as a guest professor at IIT Gandhinagar. And he, for us professionals, is a beacon of our fight regarding the engineer's bill and our recognition, because he's in the thick of the whole thing and he knows the latest developments as well. I'm sure he will educate us as to what is the present status of quote unquote engineer's bill. His passion, of course, remains to inspire the next generation to adopt the civil engineering as the first choice for studies and profession. I'm sure we are going to have a wonderful session listening to him. So, welcome to you, Professor Tandon. Stage is yours. 1 hour is the time that is scheduled.
Thank you, Dr. Kalgal. Can you see my screen and also hear my voice?
Yes, sir. Both, yes.
Okay. Thank you very much, Dr. Kalgal, for the introduction. Sorry?
No, that is some noise there. Diksha, please mute all the people except Tandon.
I think I wish to thank the Association of Consulting Civil Engineers for inviting me to this webinar, because I think it is most timely. And I also wish to thank the participants for taking interest in this subject of what exactly is happening to our profession. These are indeed troubling times for the civil engineering fraternity, with the engineers' bill at a standstill and the architects snapping at our heels, so to say, to try and take over our dignity and honor, which we have strived for generations. They, in one stroke, they want to just make an amendment to their bill and take away all that belongs to us. and make us in the process subservient to that profession, which we will not accept. So today's lecture, I think you have enough lectures on the subject of engineer's bill. I will be touching only a few points of it, but I want to tell you about the profession that you are in and why you should be proud of it and how it has developed from the past onto the present and in which direction it is going. In the past, civil engineering masterpieces were designed and constructed by persons who did not have a degree to practice but possessed enormous intelligence and skill. There was a time when there were no degrees. The degrees have started only maybe 100 years ago or something like that. But before that, there have been civil engineering masterpieces, and some of them I would like to talk today and explain to you what they were. Of course, in a 1 hour presentation, you cannot cover everything, but I will try to cover a little bit of each: past, present, and future. In the past, I think we should be proud of the Indus or Harappan civilization. That is 2600 to 1900 before the Christian era. So that means we are talking about some 4,500 years ago. That is when this Indus civilization took root. And then we will talk about the Ajanta Ellora caves, which came a little later. There is a most interesting thing about living root bridges, which are still there in Meghalaya, which I want to talk about. And then, of course, a few words about the engineer's bill. This is regarding the past. So let's start. This is what the Indus civilization was. You can see some kind of an urban planning, baked brick housing, elaborate water management systems, and clusters of non-residential buildings. This is where the Indus Valley civilization took root along the Indus Valley River, and the engineers at that time, they may not have had a degree, but they tackled the challenges by yearly floods of the Indus River. This is where they were located most of the time in Sindh, and an increasingly arid run of Kutch, that is near, in Gujarat. That is the area which had no rain at all. It was arid. So there are many, many sites of spread over the portions which you see shaded in the map of India on its northwest corner. This is another picture of the civilization, and at its peak, it seemed to have catered to between 10 and 15 lakhs of population. This is about a class B city kind of population, and they took care of that, and that requires quite a lot of planning. And in these cities, whoever discovered them were not impressed by the imposing pyramids or royal tombs or rich treasures, but for their less glittering achievements, a high civic order. And that is the sign of civilization. The main points about excellence in civil engineering which we can find are town planning, construction techniques, sanitation and water management, environmental changes tackled with surprising foresight and impeccable execution. The culmination of work in 1861 with the founding of the Archaeological Society of survey of India during the British Raj was when this Indus Valley civilization was unearthed. So it was not very long ago, maybe 150 years ago is when we found out about this amazing piece of information. Next, I want to talk about the Ajanta and Ellora caves, which are a complex of unique artistic creation. Ajanta and Ellora caves are designated as UNESCO World Heritage Sites and contain some of the finest Indian paintings and sculptures. Ajanta caves are Buddhist sites and were used as a retreat by Buddhist monks. Built in the 2nd century BC and 6th century AD. I mean, this is the period over 800 years that all these paintings and the caves themselves were built. Ellora, on the other hand, came much later, and it is a mix of Hindu, Jain, and Buddhist sites. And this was built during the 6th and 11th century AD, so many years later. These are rock-cut caves containing carvings, and these are some of the best examples of ancient Indian architecture and sculpture. These caves were built and sponsored by the Indian rulers of those periods and brilliantly camouflaged by thick forests. Amongst the greatest examples of rock-cut architecture is carved with technological exploitation. So in all this, civil engineering, as we know it today, played a vital part. These caves were discovered by accident in 1819. That is just about 200 years ago. And how were they discovered? John Smith, a young British cavalry officer, was on a tiger hunt when he spotted the mouth of a cave high above the Waghora River. Constructed over an 800-year period, like I explained, the Ajanta caves span a massive rock face in Maharashtra and are filled with ornate frescoes considered masterpieces of Buddhist art. From this, you can see how this whole Ajanta caves were so well camouflaged that nobody knew about them till something like 1819. And they were built the beginning of the many centuries ago. Let me just go forward. These are some examples of paintings. I think if you read about bodhisattvas who embody compassion, these are followers of the Buddha, and they always have, a downward looking glance, which is supposed to be compassion in their own words. So these paintings may have faded, but they still are looking beautiful. At this point of time, I want to talk about not a civil engineer, but somebody, Mr. Prasad Power, who has taken on the task of creating a restored digital image that matches the original when it was painted some 2000 years ago. That painstaking work has been the obsession for 10 years for artist, photographer, and restorer. That is what he is, Prasad Power. And according to his own calculations, he will cover the entire set of caves, I think 39 of them, and all the paintings. But for that, he requires 120 years of life. So may God give him a long life and let him restore these paintings. This is Ellora, which is the largest single monolithic excavation in the world, and the great Kailash temple, which you see on the screen in cave number 16, It represents the epitome of Indian rock cut architecture. The 34 caves are actually structures excavated out of the vertical face of the Chernanbri hills. So you can see how from a rock mass all this has been cut, and there are 34 caves. This, of course, is the biggest one and the largest monolithic excavation in the world, the Kailash temple. So let's come to another item of the past, which is, can you grow bridges instead of constructing them? You think it's possible to grow bridges? Yes. If nature and man come together, it is possible. Around Cherrapunji in northeast India, there are living root bridges. They are breathing. These bridges are not constructed but grown. The development and maintenance of living root bridges, that is what they are called, is a community affair. Initially, a length of bamboo is secured across a river divide, and a banyan plant, and it's got this funny sounding botanical name, is planted on each bank. Over the months and years, the roots and branches of the rapidly growing ficus, that is the botanical name, are trained along the bamboo until they meet in the middle. We call this type of construction these days cantilever construction technique. At later stages in the evolution of the bridge, stones are inserted into the gaps and eventually become engulfed by the plant, forming beautiful walkways. Later still, the bridges are improved upon with the addition of handrails and steps. This is taken from somebody called Timothy Allen from humanplanet.com. Let's see some pictures. This is what I call the cantilever construction. That means that from the banks of the river on both sides, you are cantilevering out and then meeting at the center and then making a bridge. This is the Panat Sangchu bridge, incidentally, in Bhutan. And here is our living root bridges of Meghalaya. You can see the two banyan plants, one planted on each side of the stream. The total length is about 50 meters and the width is about 1.5 meters. And a few of them are still existing. And incidentally, this technique is still going on in Meghalaya, or in this area which is called Cherrapunji, which was, if you remember the old days, it had the maximum rainfall in the world. And this still attracts tourists from all over the world because they want to see how bridges are made, not made, how bridges are grown, not constructed. This is what it looks like when it is nearing completion. You can see the pathway is laid. These are essentially pedestrian bridges. You can't take a metro over it, incidentally. It's not a metro bridge. I mean, it needs to be, I think it is just nearing completion, so it will be beautified and put a railing which looks slightly better, and a pathway which will be properly paved. Now, we in all practically every city are looking at these two bridges, one over the other. I have shown only two examples, Jaipur and Nagpur, and you can see the two-tier or the double-decker bridges. I mean, at the top you have the metro, and at the bottom you have the highway. This has become more or less the norm, and these type of bridges are being constructed at many places. But what about the living root bridges? Here is a double-decker. So it's not the first time that somebody has thought of a double-decker bridge. People thought of it some more than 500 years ago because that's all one can say about it, because some of the bridges which still exist are about 500 years old. Okay, engineer's bill. I want to tell you a little bit about the past of the engineer's bill. A committee was set up by the Planning Commission in February 1966, and the report submitted in 1970 under the chairmanship of S.G. Barve. The terms of reference was study the problems relating to technical consultancy services. The recommendation 1. In order to develop the profession on healthy lines and to avoid undesirable elements, practices, there should be an All India Institution Association on the lines of the Indian Institute of Chartered Accountants to lay down proper standards of education, experience, capability, capacity, etc. The Chartered Accountants Act actually had come earlier, and I will tell you when it came in the 50s. So that is why he's referring to that, and that is the model along which we should go. Recommendation 2, legislation could be undertaken to make it, the institution, a legal entity parallel to the Institute of Chartered Accountants, which means that it should become by an act of parliament, it should become a legal entity. That's what he meant, and this was in 1966 to 1970 when this S.G. Barve wrote his report. Let's come to the present. I want to talk about tall buildings and the Mickey Mouse architecture buildings, and of course, the present status of the engineer's bill. So, Fazlur Khan, he was perhaps one of the greatest structural engineers of recent times, and he died in 1982 at the age of 52. The Empire State Building, which was made in 1931, and of course the Chase Manhattan Bank building, made in 1961, they consumed about 275 kilograms per square meter of structural steel. When Fazlur Khan invented his tube concept, the amount of steel that was consumed per square meter was only 145 kilograms per square meter. So you can see that what a fantastic development it was for tall buildings. And as you know, the Google Doogle, that means that the Google masthead, whenever there is something important, they put the person's photograph there, or building or whatever. So there, on one of his birthdays, on birth anniversaries, in recent times, I think this was about four years ago, they mentioned Khan's innovative tube system made it cheaper, safer, and easier to build super tall structures, enabling the look and densities of our cities today. So what is this tube system? The tube system is that you have a central core, which you can see in the center here. And this is what houses all the services and utilities as well as lifts. There is no structure in the middle. There are no columns inside. The structure is located on the periphery, as you can see here. So this is what a tube system is. It can be circular, it can be rectangular, it can be square, but it is a tube nevertheless. Let's talk about another piece of information, which, as far as tall buildings are concerned, the first person who thought of a 1600 meters tall building, that means they used to call it the mile high building. The concept was made by an architect who was one of the most, and still is, the most famous architects of all time in America. His name, what is his name? Frank Lloyd Wright. So he's the person who came up with this idea that you can have a 1 mile high building and it is perfectly feasible. He was a little unsure about the structure and he admitted it. He wrote a book on the subject also somewhere in the 50s when he came up with this concept that he's not sure about the comfort of the inhabitants of the building because of the shaking that will take place. Of course, if there was a Fazlur Khan or somebody like that in those days, he would have told him how to take care of that also. So the next building, this is only an inspiration. We have not reached a mile high building yet. The kilometer high building is under construction and it should have been completed by now, but because of the pandemic, I think it is still under construction. And this is in Saudi Arabia. It's called the Jeddah Tower. And the present record, as you know, is Burj Dubai. It is 828 meters. But what is surprising is that what Frank Lloyd Wright imagined in a sketch, the buildings which are coming up, the tall buildings, how similar they are in shape. They look like miniatures of the same building which Frank Lloyd Wright had imagined. But tall buildings had a lot of financial challenges and technical challenges. And just to name a few financial challenges, they do not generate profits by themselves. Money comes from property development from surrounding areas. You cannot charge too much rent from people and collect enough money to justify the money that you have spent. But it comes from the development around it. And if you go to Dubai and visit the Burj Dubai, you can see what a fantastic amount of property development that has taken place around the building. And that is what is giving them the revenues. Technical challenges, there are quite a few. For one, pumping concrete, high strength concrete, it requires special mix design to enable it to be pumped. And the pump lines at the moment, whatever is available, they can sustain a pressure of about 400 atmospheres. But if you want to pump concrete higher than that, then you will have to do some two-stage kind of a pumping. Fire risk in tall buildings is another area which is a big technical challenge. Evacuation of a building. What they found is that after the World Trade Center towers collapse, how much time it should take for the building to be evacuated. So people came up with all kinds of schemes, including that people should keep a parachute with them. And if there is a fire, they should just jump out of the building and the parachute will safely take them down to the road level. I don't know whether this will ever come true, but this is what one of the scheme was. The lifts, the travel up, the vertical traveling of the people, that is the other big issue. At the moment, the travelator or rather the elevators can go up to about 600 meters. So after that, you have to have another set of elevators to go further. And the other is that you cannot go at a very fast speed. Some 10 meter per second is about the maximum. And why it can't go faster? Because there is a rapid change in air pressure, and you will get sick if it goes any faster than that. There is another gentleman called Eugene Sui. He's a American architect, and of course, it's a, I don't know, Chinese or Japanese name, who must have immigrated years ago. He's come up with the Ultima Tower, which is 2 mile high. This is just a concept, it has not been made. But if you can see on the right-hand side, in comparison, like for example, you see the Burj Dubai, this is where it is. And we are talking about something which is about that tall, as you can see here. And naturally, the shape has undergone a slight change. It is not as narrow as the Burj Tower and whatever Frank Lloyd Wright had imagined. Here at the bottom, you require a rapidly increasing moment of inertia in order to be able to take the wind pressures which are coming from the, from the top of this huge height of the building. That is why you have to change the geometry completely. And so the estimate of this architect is that it can house 1 million people. It will have over 500 floors, and 150 billion, he thinks, is a reasonable price for such a tower, because it's like a city. And according to him, you don't have to leave the building during your lifetime. You can be born there, you can work there, educate yourself there, and finally have a old people's home inside so that you can remain there. You have hospitals to take care of you. And finally, there is also an incinerator where you can be, your body can be burnt. So that is what this concept of this gentleman is as far as tall buildings are concerned. These are interesting concepts, and we have to look at it from the point of view of the structural engineering point of view, that this imagination is all right, but somebody has to design them. And I think that's what is going to come in the future. Here is another fascinating concept by another architect. Each floor can rotate about the central vertical axis. Can you see the each floor? It's made. It's like a Rubik cubes. If you played around with that many years ago. So what you are seeing today from your balcony, for example, may be totally different from what you will see tomorrow, because the whole building, not the whole building, but the whole story would have rotated. There is also a talk by this David Fisher that supposing you had a button in your flat, and of course if you own that whole story to yourself, then you could press the button and decide which is the view that you want to see. So these are challenges which structural engineers will have to encounter in the future. Of course, these are turning torso, as you can see, this beautiful building in Sweden, 54 floors, it is existing. You can see another one which looks like a snake, and this is in Abu Dhabi, 160 meters, 35 floors. You can see another one which, well, it looks like some kind of a pistol or gun, but this is not existing. This building is existing. This is in called the Dancing House in Czechoslovakia, Prague, and it's an architectural masterpiece in downtown Prague. It got its name due to its shape. The original name was Fred and Ginger, If you have been seeing some old Hollywood films, you would remember the name of Fred Astaire and Ginger Rogers, as they were the greatest dancers in Hollywood. And so many movies were made just to exhibit their dancing. And this resembles a pair of dancers. It was designed in 1992 by a Croatian Czech architect, and it was finished in 1996. But you can imagine the work that was required to make the structure stand. Here's another building in Bangkok, which is called the Elephant Building. If you can see the forward tower on the left extreme, that is the trunk, and you can see the eye of the elephant. And of course, you can see the tusk, which is colored yellow in this case. And all these little windows that you can see, they are housing different offices. So this is amazing kind of thing, and what kind of structural engineering would have been involved in to put the make the imagination of somebody a reality. I mean, even if you look at the Burj building today, which is the tallest building, the major part is not really the architect. The architecture can imagine, it can do, he's taught space planning. Of course, that is his job. But it is the skeleton of the structure which is most important, and the shape is not decided by the architect. If the building becomes too tall, it is decided by the structural engineer as to what kind of a shape it should have. Here, the hashtag tower in South Korea, another amazing building. This is already in existence. Now, let us talk about the engineer's bill a little bit. The need for accreditation of professional civil engineers in line with Barway report. I hope you still remember the Barway report, which I talked to you about in the past part of the first part of the presentation. So how can this accreditation be done? And why should it be done? And how should it be done? Why? India has a high vulnerability profile. Natural disasters like earthquakes, cyclones, floods, landslides, man-made disasters such as pollution, unsafe buildings and bridges, haphazard planning, overcrowding in cities and road accidents. These calamities threaten India's economy, the safety and security of the public, as well as its sustainable development. That is why it is necessary to have accreditation. Civil engineers, by education, training, and experience, are well equipped to make a significant contribution to ameliorate these hazards. Now, who is a professional engineer? People often ask this question. A professional engineer is actually an accreditation for competence and responsibility. Both of them come together. The practice of professional engineering means any act of planning, designing, composing, evaluating, advising, reporting, directing, supervising that requires the application of engineering principles and that concerns the safeguarding of life, health, property, economic interests, the public welfare or the environment, or the managing of any such act is called, the person who does it has to be a professional engineer. In cases where public safety, property, or welfare is concerned, it must be required that an engineer be licensed or registered. How can this be done? In most countries, I mean, I have named only a few which we can find easily on the internet. Australia, Canada, Japan, Malaysia, New Zealand, Pakistan, Sri Lanka, South Africa, Singapore, Tanzania, USA, etc. All professions, or at least most of them, such as engineers, are invariably governed by an act of the government. In India too, many professions are indeed governed by acts of parliament. The Indian Medical Council Act 1956, Advocates Act 1961, Chartered Accountants Act 1949. This is the one that was referred to by the Barve Committee report, because they had this living example of how a profession should be regulated. You have the Cost and Works Accountants Act. You have the Architects Act 1972. Much before the Architects Act was even thought of, the Barve report was already tabled. Unfortunately, some things take a long time to fructify, and there was not enough interest in it. The population of engineers in India is about 80 lakhs, and it is increasing at the rate of 15 lakhs per annum. We have 3,500 colleges, 17 lakh seats, and now you compare it with the chartered accountants. Against 80 lakhs, they are 2.4 lakhs, and only about 50% are in practice. And they have some act which was made in 1949, and we are sitting and waiting and languishing with 80 lakhs of engineers. What is the other current development? In 2018, September, Mr. Sridharan wrote to the Prime Minister, Narendra Modi. You can see the letter. I only reproduced the first part of the letter. Licensing through Professional Engineers Bill. So he was the one who sort of what is that called? Shook it again. That is the only word I can say. We have been trying for ages, but as a matter of fact, not now, as you know, from 1970, when the Barve Committee report came out, from then we have been trying. And then he wrote a letter in 2018 about the Professional Engineers Bill to the Prime Minister, and the report and the response came from the Ministry of Human Resource Development, Department of Education. I am directed to refer to your letter number so and so received through Prime Minister's office. This particular letter, which you see on the left hand side. In this regard, it is hereby informed that the All India Council for Technical Education, AICTE, has constituted a committee under the chairmanship of Professor M.S. Anant, former Director IIT Madras, for preparing Professional Engineers Bill. The terms of reference of the committee are as follows. Number one, review of the existing Professional Engineers Acts enforced in foreign countries. Number two, formulation and preparation of Professional Engineers Bill. Three, this is the last part. For further information on this bill, you may approach AICTE. But these people have to prepare the bill and take it to the parliament. I mean, that is what the terms of reference of this committee are. The current situation is that after so much discussion and stakeholders meetings and so on and so forth, of which I was also a part of, the file or the draft Professional Engineers Bill is lying with the Ministry of Human Resource Development, and that's the point at which some activity has to take place. I hope it will take place soon. Future, let's talk about future. Predicting earthquakes. We are talking about future of civil engineering. Interlinking of rivers, and of course we will talk about the engineers bill. The global seismic map is here, and you can see these red portions. They are the ones which are the most active, seismically most active areas of the world. And in the Indian subcontinent, it is the Himalayas where you have the maximum activity. I have to go back. If you want to understand what is being done, let us go back many, many million years ago. 500 million years ago, there were two large land masses called Laurasia and Gondwana, and they were joined together. About 200, I think, I beg your pardon, this 520 is not correct. It's 200 million years ago. It's separated into two separate land masses. If you look at the current political lines along which the world is divided, these figures show you 500 years ago, that is that when they were joined together, the one on the left hand side. If you put all those countries together, this is what they will look like. I want you to particularly take note of whenever you see India. For example, India is located here. And the current present day, what we call tectonic plates, that means that there has been shifting of the entire land mass. First, it broke up into only two pieces. Now it's broken up into many pieces. And these are called tectonic plates. And at the edges of these tectonic plates, and you can see the Indian plate here, it is just to the north of it is the Eurasian plate, and to the south of it is the Indo-Australia plate. So now these plates, they are not stationary, they are still moving. Why they are moving? Well, in the mantle, which is about 3,000 odd kilometers from the surface, that area, there are convection currents, and these currents are responsible for the shifting of land masses on the surface. And this was discovered by Alfred Wegener, who these days we call him a geophysicist and meteorologist, because there were no such terms at that time, but now we know. But he explained why and how these continents shift. If you look at the Indian plates, it's particularly interesting. After breaking off from Gondwana, which is the the lower part of the two land masses, it started moving northwards, and at about 50 millimeters per year. It is a MYA means million years ago. The what is it called? The currency is million years. It is not 1 year, 2 years, or centuries. It is million years. So the Eurasian plate was moving north at only 20 millimeter per year. So Eurasian plate, which you see at the top, and the Indian plate. The Eurasian plate is moving at a much slower pace, and the Indian plate, as you can see, is rapidly catching up, and it has caught up. Now, around 70 million years ago, this is what is found by the MIT researchers, India started moving at almost 150 millimeters per year. From something like 50 millimeters, it became 3 times the speed. And this itself was about twice as fast as any tectonic plate was moving. The result was an impact with Eurasia. This plate, what you see at the north of the Indian plate, there was a cataclysmic impact that created the Himalayas, the tallest mountain on earth. Here you can see again, what is happening at the moment is, as we are sitting, we don't know, we don't realize, but the earth is moving, or rather the Indian plate is moving, and it is pushing the Eurasian plate, because it is that is not moving fast enough. And so there is a term called subduction, which means that the Indian plate, you see, if you are pushing against each other like these sumo wrestlers, either you stay in the same place and the energy keeps on accumulating if you put more and more pressure, or one person goes down and the other goes above. So this is what is going happened in the case of Himalayas. After the cataclysmic clash where they were formed first, now it is moving fast and there is a subduction. So it is now moving at the rate of 19 millimeters per year because it is slowed down tremendously. 19 millimeters per year means about 1.9 meters in 100 years. And it means about 19 meters. I think you can at least see 20 meters. That is what will happen in 1,000 years. In 250 million years, the ocean will reach the Himalayas. So if you want to invest in a sea-facing property, you have to invest at the right time. Then let's go forward. Oh, I think this business of something coming up for annotation, and I cancelled that, and this is what the result is. So I will have to go back. Let me see if this will succeed. And I do request that people don't put in, any of these annotation business, because then this will come to a halt.
You are back, sir.
Now it doesn't move. I'm sorry, but it has stopped moving. So let me see if I can. What should I?
Just press the down arrow.
Yeah, down arrow doesn't work. Up arrow doesn't work. Sideways arrows doesn't work. Escape arrow doesn't work. So what I will have to do is probably stop sharing and see whether I can share again, whether it will come. If it doesn't come, then I'll have to, of course, go out and join again. Let me see. Resume slideshow. Let's see. Can you see the new slide?
Not yet.
Not yet.
No.
This is still the old slide you can see?
No, sir. We are seeing the standard slide of ACC. Professional.
Okay. So that means that this doesn't work. You will have to share again. That is what it means. And let me try again. Sharing. It's not so easy. Okay, it's come down. It come below. Let me see whether this thing works. Now, can you see any of the slides?
Yes.
Okay.
Not in slideshow mode, but we are seeing the,
Now it's on slideshow mode.
Yes, sir. Yes, sir.
Okay. Now, what happens is that knowing all this, there is a professor, Roger Wilhelm, of the Colorado University in the US, who has spent a lifetime studying this Himalayan movements or movements which take place near the Himalayas. And by a combination of simple reasoning and high technology, he has used the GPS system to measure the movement of the Indian plate. It may be only 19 millimeter per year, but the technology is such that you can have an accuracy of 3 millimeter. So you can still measure the movement, which is about 18, 19 millimeters per year. So he has said that the result is clear. India is moving northward towards southern Tibet at 18 millimeters per year. And the high mountains are rising at about 5 millimeters each year. Now, you see, as I explained in the last slide, if you have a, two land masses, even if they are moving at such a slow pace, they've got such a tremendous momentum. And if they don't move, they are building up energy or storing energy, potential energy. And when they move, that is when we feel the earthquake. And these earthquakes, it is better to have frequent earthquakes because they will be much smaller in magnitude rather than one big earthquake once in 500 years or 1,000 years, that is not what ideally we should hope for. We should hope that the energy is released periodically by subduction or whatever means, so that the energy is not building up and then suddenly one day you get this subduction and a huge amount of energy is released and a large magnitude earthquake. So they've got something like 26 GPS survey points. And if you see this picture on the left hand side, this is what these saucer like kind of things, they are 26 in number. They are put all over the Himalayan range and they are being measured by GPS. So the only problem is that every time you want to take a reading, you have to physically go there, and there are 26 of them, and it's an arduous task climbing all these places and then take the readings. But this will tell you what is happening. So by studying the previous big earthquakes on the Himalayas, and there are 4 of them which have been identified: the Kangra 1905, Bihar 1934, Shillong 1897, and Assam 1950, from east to west. Now these have all been plotted, and from 1750 onwards, and they know how much of energy is building up. At the moment, what we call is a slip deficit. That means that if the slip has not happened, you are building up energy. And what is the current status of that? According to Professor Bilham, there is a magnitude 8.64 of them. That is the equivalent of the slip deficit. So this is not such a healthy thing to have if we don't want large scale destructions. I want to talk next about the interlinking of rivers. Rajendra Singh, known as the waterman of India, believes that the Third World War will be about water. And you can see what is happening here. The wells are drying up. Groundwater abstraction countries. If you see the list of where you are not going to get a medal, but where the maximum abstraction is going on, is India is at the top. We may not be getting any gold medals, but we are at the top here, all right. And the others, China, United States, Pakistan, and you can see how much kilometer cubed per year is the abstraction of groundwater. And this accounts for, these 10 countries account for 72% of the global groundwater abstraction. So these are the biggest culprits in as far as the groundwater depletion is concerned. But these are depleting very fast, and we have to find solutions. The supply of drinking water is provided by natural precipitation. It's about 40,000 kilometer cube per year. Much of this precipitation lands on sparsely populated areas. We will have to think how to get this water where it is required in large quantities. India accounts for 18% of the world's population, but only 4% of the world's water resources. So we have to do something drastic. Other countries may not have to do it, but we do have to do something drastic. Let us see the project called the Indian Rivers Interlink Project. The idea is to transfer surplus water from one basin to another deficit basin. So it's a question of transferring from flooded rivers to those with drought and scarcity. That is the whole thing. And the interlinking of rivers is a huge task and a very expensive, but it is one of the largest civil engineering projects ever conceived by mankind. And it has got a lot of components, and this is the map. the original map that was made. And of course, it has still remained as a map only. The history behind this, I think, is very interesting. In 1958, it was General Sir Arthur, British general and irrigation engineer. He came up with the ambitious proposal of connecting all the major rivers of India. Then in 1970, Mr. K.L. Rao or Dr. K.L. Rao, Minister of Irrigation and Power in the Government of India and a civil engineer, revived the plan of linking the Brahmaputra and Ganga basins, the water surplus areas, to the central and southern parts of the country, the water deficit areas, to form a national water grid. In 1999, there was an interlinking plan which was revived again by the Commission for Integrated Water Resources Development after several attempts. It was in 2002 that the then President of India, Abdul Kalam, revived the inter-river linking project, after which an application requesting an order from the Supreme Court on that matter was submitted, which was converted into a writ petition. And finally, in October 2002, the Supreme Court ordered the central government to initiate work on interlinking the major rivers of the country. The Supreme Court also ordered the constitution of a special committee for interlinking of rivers, headed by the Minister of Water Resources. And I want to show you the pictures of these three great gentlemen. It is very interesting. You know, of course, about Dr. K.L. Rao and Dr. APG Abdul Kalam, the People's President of India. But let me tell you about this Britisher. He was an irrigation engineer and he did a lot of work in India. And he was asked to appear before a House of Commons committee to justify his proposal to build an anicut across the Godavari. And his statement in the court was, "My lord, one day's flow in the Godavari river during high floods is equal to one whole year's flow in the Thames of London." And he was, of course, not reprimanded after that. What is the cost of the project? 560,000 crores at 2002 prices. It means an annual outlay of about 16,000 crores over 35 years. If you just divide 560,000 crore by 35, you will get this figure. The cost consists of three components: something on the peninsula, something on the Himalaya, and of course the hydroelectric component. And the budget in 2014 and 15 was earmarked as 100 crores for the preparation of the DPR. So can you imagine something that started as an idea in 1858? We are now looking at, you know what we are looking at. Just 1 minute. I think I want to show you one more slide of the of this engineer's bill. What is the future of, as far as the engineer's bill is concerned? Many challenges face the civil engineering profession in India. Indian engineers are still languishing in the unorganized sector, and so is the draft of the engineer's bill in the Ministry of Human Resource Development. After several rounds of discussions, what are the solutions? Some of the challenges can be addressed if we had a legal entity parallel to the Institute of Chartered Accountants, as envisaged in the Barve report in 1970. It is a sad commentary that even after half a century, this important piece of legislation has not seen the light of day. What is the other solution? Seek divine intervention. That's all I can say. I want to show you this beautiful slide It is our ancestors. You know, our ancestors of human beings at least, they are laughing at us because our civilization is lost. You can see this man with his dog. This is the civilization that we are talking about, and he's looking at a map which should generally indicate to you where you are at the moment, and it says you are lost. And these people, as you can see, they are giving each other not high fives but at least low fives, and laughing at us. I think with this I would like to close my presentation, and thank you for your kind attention.
Thank you, Tandon. That was a wonderful presentation. Towards the end, you did mention that we haven't got a gold in Olympics, but let me inform all that we did get a gold in javelin just now. So that's a good news.
Fantastic. You know,
Yeah.
I was when my lecture started, half my attention was there, and just
Yeah.
at that time we got a bronze medal. Our what is he called? Punia.
Yeah.
Punia, our wrestler, he got a bronze medal today.
Yeah.
He lost yesterday, but today he got it.
Yeah. So the good news is that at last we got one gold medal, that is in javelin.
Yes.
So with that, I do thank you for a wonderful presentation. We'll give you a 5-10 minutes rest, Professor Mahesh Tandon, and I will request Ultratech to make a small presentation which is called as Snippets from Ultratech. Mr. Pandyan Kalaimani is there, so he will make the presentation. Pandyan, over to you.
Thank you, sir. Myself, Pandyan Kalaimani, looking after special concrete for Tamil Nadu and Kerala Ultratech Remix Concrete Division. So, let me start my presentation.
Oh, do I have to unshare or something? No, it has got
Yes,
nothing
sir.
like
You have to
Not
stop sharing, sir, so that I can.
do I have to? Okay, so 1 second. Where is that unshare button? No, that is not alive.
Just 1 minute, 1 minute.
Will you be able to do it, madam?
Yeah, I think the office will be able to do it.
Okay.
Give rights to
Sir.
Pandyan.
Sir, now give stop sharing.
I should stop sharing. Normally, it's the share button which you have to press, and it says stop sharing.
1 minute.
1 minute. I'll just close my presentation. Then it will work automatically, right?
No, sir. In the bottom, in third icon, try to stop share. There is an option.
1 minute. You know, there is no icon which is switch audio. No. If I press this one, I'll leave the meeting. Stop.
Don't leave.
Pandyan sir, now you can share.
Yes.
Now Pandyan can share.
Yes.
1 minute, I will make presenter.
Please.
Okay, please go ahead.
Actually, these icons are hiding me from slideshow mode.
No, go to the bottom. There is one more provision to make it slide.
Yeah. Is it okay now? Is it okay now?
Not yet.
So for me, screen is full.
Okay, but it's not
visible. Is it okay, sir?
No,
You have to put it on slideshow. slideshow mode.
Yeah, for me it is looking like that only. I'll just try to shop. Is it okay now?
No.
Sorry, sir. 1 minute. Just.
We can see your whole
Slideshow mode is not.
desktop, but you have to put it on slideshow. You can do it only from your own PowerPoint.
Or press F5, sir.
F5 is looking like volume button. 1 minute.
Maybe for paucity of time, you can continue with this kind of arrangement and just start going from slide 1 to 2, 2 to 3, etc. Unless there is an animation. If there is no animation, you can go ahead.
Yes, sir. So the product which I'm going to present here is Ultratech Free Flow Plus, which will act as a solution to many construction related problems. Ultratech Free Flow Plus, it is not just a flowable concrete. It is designed with special admixtures and ingredients through which we can achieve smooth surface and reduce plastering cost. High flowability reduces manpower significantly. Best solution for places with intricate reinforcement, and it will help to mold any accurate shape and good aesthetics with good aesthetics. Ultratech Free Flow will undergo tests like flowability test, U-box test, V-funnel, J-ring test, L-box test to maintain the international standard. Moreover, Ultratech Free Flow will achieve better strength and durability compared to conventional concrete due to as low as 0.32 or 0.3 water cement ratio, and minimum 550 to 600 kg of cementitious is maintained. Also, it will be significantly better in achieving durability parameters like water permeability and RCPT. So now the screen is moving, sir.
Yes, yes.
Yeah, I just tried to list down the solutions through Ultratech Free Flow Plus. The main problem addressed is due to congested reinforcement, vibrators are not effective, and it leads to voids in concrete. So with Ultratech Free Flow Plus, it does not need any vibrator, and concrete can be compacted almost 100% without any vibrator or manual intervention. And another problem is uneven honeycombed concrete surface leading to high plastering cost and repair cost, and safety also is compromised. So particularly in column or deep wall where vibrator cannot reach out. So when people try to vibrate it manually, that vibration is not 100% effective. And through studies, it is found that those vibrations are effective only up to 90% or 95% maximum. Whereas with Ultratech Free Flow Plus, we can achieve almost 100% compaction without any vibrator and any much effort. And also we can achieve very good strength, and the strength would be uniform across the structure. That is very important. Structural designers are designing concrete of M30 grade, M25 grade, and that is getting achieved in cube strength. Whereas in actual structure, because it is casted manually, so one must think whether the concrete strength is uniform across the section or not. With Ultratech Free Flow Plus, we can achieve uniform strength across the structure cross sections. And generally with concrete, curvilinear and architectural shape is not that easy, but with Ultratech Free Flow Plus, we can achieve any kind of architectural shape and patterns, and letters also can be imbibed in concrete. And another solution for the problem is reduced structure life and reinforcement corrosion is the common problem. When RCC was invented, people were thinking that it is going to last for 1,000 years. But in reality, within 50 years, sometime even within that structure getting deteriorated, and mainly it is due to corrosion, because when reinforcement getting corroded, it bulges up to 5 times, and it push the concrete cover out, and deterioration start taking place, and repair work or rehabilitation start taking place. But with Ultratech Free Flow Plus, we are maintaining cementitious content of around 550 to 600 kilogram, and water cement ratio we are maintaining as low as 0.3, which ensures high impermeable concrete that resists sulfate, chloride, carbonation significantly. And another solution is cost of plastering and painting is very high nowadays, and with Ultratech Free Flow Plus kind of concrete, we can achieve fair finish surface. And nowadays we are trying with the color also. Although color won't be 100% uniform, it may give aesthetic appearance, and architect can try for it. But when architect goes with the gray color itself, definitely it will act as a cost saving measure. And labor shortage in construction industry and increased labor cost is a problem. With Free Flow Plus kind of product, we can achieve significant labor reduction. And we have just made some case study in which we have found that almost 20 to 30% labors minimum can be saved with Ultratech Free Flow Plus kind of self-compacting concrete. This is the table of comparison we have made with one of the project in Chennai. And another case study also was made, and almost 10 labor count was we were able to save. So you may ask, what is different in Ultratech Free Flow Plus? So in Ultratech Free Flow Plus, we claim that vibrator is not at all needed, and you will get excellent smooth finish wherein there will not be any honeycomb or any touch-up work is needed, and almost we can ignore plastering or any other cost like wall care putty. So with that brief presentation, I'm just signing off.
Thank you, Pandian. So, Professor Tandon, now we will open it for question and answer session. Pandian, you can unshare so that we can see the full screen and all the people. And the procedure for question and answer, as was mentioned last time also, is that those who want to ask questions, please raise your hands and I will call. And once I call, you can come and start the question. And request you to kindly ask only one question per head, and so that others also get a chance. So can I have a show of hands? Okay, I haven't seen any hand going up yet, but let me start with the question. Now, my question will be first. Okay, I'll give preference to Professor Krishnamurthy. He raised his hand. Please go ahead, sir. Please unmute yourself.
Actually, I can wait, but
No.
just a comment. I have heard and read about Professor Tandon, but I'm glad and proud that I'm able to listen to him today for his very erudite comments. That said, it is true that our Factories Act of 1948 has not been changing too much, and wherever it has not been disseminated down to the people who use it. But I feel privileged that a few months ago, the government of India invited me to participate in the revision of Factories Act 1948 with about another 15 or so experts from all around the country. So although I don't want to take the time to detail the work, I would like to assure the audience that now the whole committee is looking at the entire spectrum. It goes to volumes and volumes. So we already had 8 meetings, and each meeting, each of us comes up with suggestions and bringing in whatever is available around the world and whatever is feasible to be done in India. So I just wanted to assure the audience that in a few months, perhaps, we will have constructive proposals for improving or revising Factories Act. Thank you, Dr. Kalgal.
Thank you, Professor Krishnamurthy. Now we have Nandakumar Ganeshan raising his hands. Nandakumar Ganeshan. Okay, looks like he's logged off. Ajit Mugdum.
Yes, sir. Thank you, sir. Sir, it was a very good presentation as usual. I heard you earlier also. Now, my question is that as you showing the future of the civil engineer, we have a tremendous.
Please up your volume. We can't hear you.
Okay.
Most of us are able to hear.
Sir, can you able to hear me, sir?
If you speak louder, it will be, unless your wife objects. You
Okay.
can
Okay. Sir, as you explained that lot of big responsibilities there on a civil engineers to build a nation, and the question of our engineering bill is stuck. So, what is the way forward, sir?
What is the way forward? I think, what can I say? We have to keep on doing our job the way what we have been trained for, and we have to self-regulate till the time these regulations can come into force, and that can come into force only when the engineer's bill is passed by the parliament and it has a stamp of the government. Only then it will make sense. Just getting somebody saying that I will also what is that, give accreditation to engineers, that doesn't make much sense unless it has the stamp of the government. And we have to try hard to get the government to do that. I mean, there was a lot of movement of it in 2018 up to about 2000. I think for about 1 year or 1.5 years there were movement, but now it is again stopped. It is just at the Ministry of Human Resource Development, and if we can somehow push them to take it forward, it is in their terms of reference that they have to get presented to the Parliament. But Parliament, I agree that the Parliament has got many more problems that it is facing, but at least they should send it up to there. We have not even reached the doorstep of Parliament. It is still lying in the ministry only.
What is the reason?
That is the way forward.
Sir, why Ajit asked this question is because one of the speakers in this series said that there is no need for engineers bill, and we just through our associations we can regulate and be done with it. So what is your comment?
No, I don't agree with that. I think we by all means let us self-regulate. That is the first thing I am saying. But if it has no stamp of the government, no stamp of the parliament, then it becomes an act. You look at all the other acts, you cannot. It has got certain rules and regulations. We are somewhat 80 lakh engineers, and you want to regulate it all differently by different associations. It's not possible. You have to. It's such a huge army. You have to have some discipline and some way of conducting your business of civil engineering. Otherwise, it's not possible. So this business of each association trying to do accreditation, I don't agree with that.
Sir,
Because that will not solve the problem. That's what I'm saying.
Okay, now Mr. Nandakumar Ganeshan.
Sir, shall I have permission?
Ajit, one question is over. Nandakumar.
Could you hear me, sir?
Yeah, please.
Good evening, sir. Thanks for the wonderful lecture. My question is for the Tandon sir is that actually I'm a structural engineer, sir. I'm having very passionate about the field of structural engineering. Actually, one thing what I feel is that like the other fields, the way that software engineering or electrical engineering or a mechanical engineering, they are developing a very fast. I feel that are we in our field also, whether the innovations are up to uh, up to their mark, or where are we, sir? For example, if in the field of mechanical engineering, electronic vehicles are in the way, uh, like in the way of computing, then artificial intelligence, machine learnings and all, they are updating. But where are we, and are we are we are competing in the terms of innovation with other fields of engineering? So,
No, I think you are right. I mean, in a sense that definitely the remarkable and I would say glittering progress what one can see in the in the in the information technology field, or even in the mechanical engineering. At least there is electric vehicles, which is a new thing which is coming up. The definitely they look more what is that, more grand, I would say. But the civil engineering, I think, is something which is, it is a slow but steady kind of a pace that you have to go. Suddenly you are not going to excuse me, suddenly you are not suddenly going to find some new material which is going to replace steel or concrete. Everything is on a laboratory scale in the research and development. That is the stage we are in as far as those things are concerned. New types of structures, new requirements are not going to come up. We already know that you have to have shelters, you have to have infrastructure for transportation, this, that. Everything is well laid out in our case. So what we can do now is only to build higher buildings, make longer spans, and certainly there is progress, but that is at the at the cutting edge of our profession. It is not seen as dramatically as you would see, like 10 years ago or 15 years ago, we didn't know what a cell phone was, and now you got a smartphone which is where you can see your daughter in playing tennis in America. I mean, it is certainly more dramatic than whatever we are doing. But it is not because they are they are more intelligent people there. It is not because of that. It is just the nature of the profession that we are in. It moves slowly, but it has to move steadily. And right at the cutting edge, yes, you will find some things which are happening which are quite interesting. I mean, like, nobody could think of that you can have a 1 mile high tall building and make it a reality. But now there are plans are afoot that you can make that. And can you imagine that you can have a building where everything is provided for you? You may be born there and you have to never go out. you can live your own life there. I mean, it is something which is another concept which I think is fantastic. You may not be able to drive your electric motor car, but at least it gives you some idea of what our profession is.
Even 3D printing is one example, sir. I mean, this is something which is very unique. Of course, how far we'll succeed, we'll see.
You see, we have been discussing about this 3D printing. According to me, its greatest use is going to come in rural housing. Now you'll ask me why. Rural housing, because we have studied a lot about the industrialized housing. Unless you have something which is industrialized and manufactured, high quality, this, that. But you cannot put in an industry which is manufacturing, let us say, precast concrete houses or components near a village. You can't. But when you see the 3D printing, the technology may be very high. I mean, to make that type of a concrete itself is I think, is a great achievement. But if you look at the equipment, it is not that complicated. It can be transported. So 3D printing, I think, apart from just showing, that you made a culvert somewhere or some house, demonstration house in IIT Madras or in Guwahati and Gandhinagar, these are the three places where a lot of research is going on. Apart from that, I think its real utility will come in rural housing when we develop it to that extent. And there are enough people, and there are people who can invest in this type of a technology. Here we are still only at the very, very latent stage, very early stages of 3D technology, 3D printing. Sorry.
Mr. Rajendran Shivaraman. Mr. Rajendran, you can unmute.
So I would like to start from the answer of Professor Tandon. The civil engineering and technical advantages are equally happening across all industries in civil engineering also. We don't get to see it and feel it because we are not everyone is using it like a cell phone or an electrically driven vehicle. And then starting from the GPS survey, the new concrete technologies and the 3D printing, all these are there equally happening along with electrical vehicles and cell phone technology. A person sitting in the new apartment doesn't feel it, how much technology has gone into the apartment he bought. We, the civil engineering fraternity, only feel it. So my humble submission here is every presentation, while we are projecting the photographs, we are giving the names of the architects who designed it. So my submission is can we make it a practice that in future presentations, we present the name of structural engineers or the companies of the structural engineering companies who designed it. If we don't popularize it, who can popularize those fraternity people?
No, certainly. I think that there are areas, I thought of it myself, but I could not find the names of the structural engineers. For example, with a lot of difficulty, I could find 2 or 3. Like I know who designed the what is that? That New York in New York we have that famous building. What is it called?
Empire State Building.
Empire State Building. I know. After so much of research, I could find the name of that. But now, and of course, there are names of the organizations. The person who designed the Burj, the Dubai, Burj Dubai, he is also designing that same organization.
Khan
is also designing the one in Jeddah, which is but there, yeah, sure. But the original idea. I mean, if you look at the concept, the visualization of something like that can be done by an architect best, because he is really the person who has been trained to think in space. Then you have to bring him down and to make the skeleton of whatever he has in mind and make him change the whole concept. Like Burj Dubai was never thought of as a tower like that, except that there was this Frank Lloyd Wright's example, who's an architect. But he knew a lot about structural engineering in those days. I mean, for a person to say that I don't know enough how to take care of this problem, this is a structural issue, itself, I think, is a great thing. But sadly, we are finding less and less people of that stature who crossed all boundaries of professions. I mean, if you look at even some of our own structural engineers, like Monsieur Verloger, I don't know whether you heard of him, but who has designed the tallest bridge in the world and the longest span. All those works that he has done, and he has given so freely. I mean, about whatever knowledge he has has to everybody. And when the other day I knew him a little bit, and I told him when I turned on this what is that called, the geographical channel, and they said that they named the architect of that for that bridge, and he said, yeah, that's how life is. They only think of what is his name, Mark Forrest or whatever his name is, Foster, Mark Foster. That is he has designed a lot of
Norman Foster.
Huh?
Norman Foster.
Norman Foster. So he's very famous architect, and of course he has done some fantastic jobs. Even he, I think, transcends this professions completely. And so does Varloje, our own structural engineers. He has such a keen eye on aesthetics. Some of the things that you see that he has designed, you will wonder how he thought of it. Or you look at the engineer architect from Spain, Calitrava. If you see his structure, his structures, there's nothing that you can think of. Like his buildings will look like a bird. So it's there are some people who are exceptional. We cannot blame them. I mean, we should not try to compartmentalize them. They are for all the professions.
Shashikant Kannur.
Hello, sir. Hello.
Yes, go ahead.
Yes, sir. Sir, my question is to Tandon, sir.
Yeah. Yes, please.
Hello, sir. Sir, good evening. So today's your speech was really great. So very much support to professionalism, and actually we are inspired. Coming to the question, sir, how do you expect the engineers of India to contribute themselves to get this engineers bill done from government of India? What should be the role play of engineers? Because so far it has taken more than half century. Why is it not possible? What is your ideology, sir? What is your suggestion?
I think we have to, like I said, we have to somehow approach the MHRD, and I will of course ask or request Dr. Sridharan to write a letter again to the Prime Minister that it has got stuck there. I'm just waiting for a few more months. I mean, because there is so much of chaos at the moment in the Parliament that to expect that they will even think of the engineers bill is something which is beyond me. But what is worrisome, I will tell you. You know, this architects amendment bill, which is going to, which they are trying to somehow push forward. I am worried that in all this confusion, where the the people are, there is no real business is transacted, and yet some bills are passed. Nobody cares about that. Either people are objecting to some, Pegasus, or somebody is trying to sell something. Those type of things. There is so much of confusion in the Parliament that in all this confusion, there should not slip in this architect's amendment bill, and it goes through because nobody is interested. That is a real danger, if you ask me. But other than that, at the moment, I think we have to somehow get the Ministry of HRD moving. Not that the draft of the bill that I have seen is some big thing that we that is perfect or anything. It is actually quite a disappointment, the bill that is being proposed. But Professor Anant Kumar, he said that there is so much of infighting in the engineering fraternity that I don't know which way to go. I said, you go in any direction. Just get the bill passed. That is your job. Once we have the bill, we'll see how to modify it. But if we don't have a bill, then this is all theoretical. And all this infighting between engineers is also theoretical. It's like those, what are the two cats fighting, and then the dog takes away the sandwich. That is what is happening. So we have to make sure that we remain together. All engineers should speak in the same voice. There should be no room for dissent. If you want to discuss something, you discuss it. But it should not be that the egos are coming into the picture and all sorts of things, because that's what happened the last time, which was not very long ago, maybe 20 years ago or less. But we lost that opportunity because of infighting. And that infighting has reached even Professor Anant. And so my request to him was that you please get us this engineer's bill, irrespective. We don't agree with most of it, but you get it. Because, you know, the engineer's bill is what? It's a engineer's professional engineer's bill for people in practice. It is not meant for a title which you can put below your name. It is not meant for that. If you have people from IIT who are teaching and only teaching, they don't need to be professionally accredited. But yes, anyone, including the people who are teaching, if they are doing any work outside, they must get accredited. Only then they can do a work which is outside. This is what the whole story is. I mean, what is the use of getting so many people accredited? Military engineers are getting, is also there. They should be accredited. Why? Are they practicing? Not that they are not doing a wonderful job for the country. That is beside the point. But they are not in practice. So the engineer's bill, as it the last amendment, the last draft that at least I saw, I was very unhappy. We wrote to AICTE that these are the various issues that are problematic in it, and you have lost the purpose of the engineer's bill. It is for people who are in practice. It is not meant for any other engineer. But anyway, what we finally said, let us get the bill. If we don't have a bill, there is nothing to fight for.
Yeah, sir, I have just one kind of corollary for this. There was also a suggestion that instead of going in for an engineer's bill, we should go for an civil engineer's bill, because all other professions, because they are not doing consultancy, there is no urge for them for this, bill. Whereas we are suffering as consultants, as civil engineers. So should we aim for a civil engineer's bill? I don't know. But this is another thought process that was thrown around.
No, I think that it is, you are absolutely right. The other engineers, there are hardly a few, a very small percentage who in other disciplines who are in practice, and where they come in contact with, the general public, their welfare, and so on. I mean, it's really the civil engineers who are mostly affected by it. And so it should be a civil engineer bill, if you ask me. But I think that if we now go back and say that you forget about the engineer's bill, let us have a civil engineer's bill, it may not be the right time to do that. The right time to do that was a long time ago. Abhi to it is called the engineer's bill, and we should, I think, just go forward with it, somehow get it, and then we can see what to do.
Okay. Before I allow Mr. Bhimrao, just one more thing that I wanted to ask was, now this architect's amendment, as you rightly said, might get slipped in and get passed also in this commotion. But I don't see how we can prevent this from happening. What are your comments on this?
You see, any bill that has to be presented to the parliament, it has to go through. There is a secretary of the. There is a
Parliamentary
minister,
Affairs
as a matter of fact.
Ministry. Yeah.
Sorry?
Parliamentary Affairs Minister.
Parliamentary Affairs Ministry. It has to go through that. Whatever is put up for the parliament, we have to make sure that we keep track of that. I mean, in the sense that either we should meet that minister
So,
and tell him,
Mr. Prasad Joshi, I mean, our Karnataka minister is now the Minister for Parliamentary Affairs. I think the
Okay.
Karnataka engineer should, somehow catch hold of him and see that, at least keep an eye on something
Yes,
which
yes.
will come edgewise, so that it can't get in.
Yes, I think that we need to do that, because unless we go and meet people, now the next generation has to take over. I mean, we have fought, maybe we have lost the battle, but we've been doing it for so long and meeting all these, and these Ministry of Human Resource Development. I don't know how many trips I have made there, but every time after, let us say, a year and a half, you go there, there is somebody who is totally new. They get shifted around so fast, and it's very difficult to. We have to keep track, I think, and even though they keep shifting, these fellows, you have to make sure that somebody doesn't really do the wrong thing and then get shifted, and we will not even know. So this Ministry of, and there is a Ministry of, there is a higher education secretary. There are several secretaries in MHRD. The one which is dealing with higher education, that's the one which we have to catch hold of. And AICTE is another institution which is which has a role to play.
I mean, that's what the government thinks, and we don't think so. But because AICT should manage business of education, they should not take our professional issues, because they are not competent to do this. This is my personal opinion. I would rate
absolutely right. If you ask me, they shouldn't even be in engineering education. Just like the architects are managed, AICT is no longer in charge of architectural education. It is the
India Council on
Indian Council of Architecture which does that. They manage that.
Okay, Mr. Bhimrao. Telegama Bhimrao, are you there?
Yeah. I'm Namaskar, sir. It's a very beautiful presentation.
Be a little louder, sir. We can't hear you.
Hello. Now okay. Now okay.
Yeah. Okay. Speak a little loud. That's all.
Yeah. It's a very nice, sir. Namaskar to everybody, and very beautiful presentation touching the past, present, and the future. Really, it's a very nice and very good presentation. And moreover, I would like to talk on the engineer speed. So, since the last so many years, it is only between closed doors. I feel it. It is not going into the people. And you are hearing, sir? Able to hear?
If you can talk a little closer to the mic, I think perhaps.
He's holding the mic close, but we are not able to hear.
So, yeah, it's okay now. Able to hear, sir, now?
Yeah.
Yes.
No, you have to speak loud.
Tandon, sir, able to hear?
Yes.
Yeah.
Sure.
So my question is regarding the engineers bill. Only this is going only closed doors. Only in between only engineers and some of the politicians. But it's not going to the people and not going to the papers, not going to the world. Why don't we protest in one day the total engineers of India? Protesting in sense not going on the roads or something else. That is why don't we debate? Why don't we discuss? Why don't you go into the papers? Why don't you go to into the news channels?
Yes.
So if you go to all these things, people at least they will understand. Otherwise, the people can be jo dikhta hai wo biकता hai. So दिखने का नहीं है तो जो बिकता नहीं है. So the same business rule. Suppose it is going to the debate in the phone, debate in the news channels, debating in the engineers, and calling the all the politicians and all these things may give the result. But keeping close and just sending the letters in me, I don't think it will take the shape even in 30, 40 years also. That's only my suggestion. Thank you very much, sir.
No, I think what Mr. Bhimrao has said is absolutely correct. You see, we people don't even know what is the difference between an engineer and an architect. I mean, this is the kind of level of information that the public has, and we are doing nothing about it. We have to make our presence felt, and not necessarily by going on strike, but but at least writing articles in the newspaper, in the general newspapers. I am not saying you should write, some high technical stuff in your journals. You can keep doing that, but what counts is this: that you have to be in the public eye, and the public eye means TV, newspapers, and of course, what in IS Shakti we started about 3-4 years ago, and now it is not there. We went to colleges, schools, to tell them what civil engineering is, and so that people get an idea as to what this whole thing is about, who are engineers and what they do, particularly civil engineers. So I think we have to somehow start that again, where we close this gap. One is the public itself, public at large, and the second is the generations to come must know what it is, who we are, and what we do.
Okay. Anyone else who would like to ask any question? Ajit Mukdam wanted to ask. I prevented him earlier. Now I would allow him to go.
Thank you, sir. In fact, I was also of the same opinion of let's go to the people, create awareness, and also take it to the street impact, sir. Why not? Why should we also protest? I mean to say, why don't we think of going to street also, sir, to push it?
Too many people are going to the street. That is the problem. See, you will get.
That's how we have to show that.
See,
never,
Ajit.
Sir, we never gone, sir.
No. Ajit, you see, every alternate day in Bangalore or any city, there are protests. People are just not taking any protest seriously. As Professor Tandon mentioned, if we go to the newspapers as well as TV channels, today people are afraid of TV channels. If something, is whipped up, you collect some 2-3 like-minded fellows and blast about this, engineers not being recognized and not being accountable, and hence so many collapses happening and so on. I think government will note that rather than your one day's protest somewhere. How many protests have gone unnoticed?
Sir, we have to bring it to the government's notice, which is sitting in the Delhi, and we have to think reaching it to them, not to the public, sir, because they're not showing a blind eye in the ears.
No, that is what, because the whole, all 130 crore people want central government's attention, but it has got its own ways of giving attention. So street protest, I mean, this is my personal, street protest may not help.
No, I think that, you look at the latest thing that has happened. This Khel Ratna Award, it has been renamed after Dhyan Chand. Why?
Yeah.
This is not it is not a political issue. It is because so many people said that we should honor that gentleman, number one, and number two, why the Khel why the award cannot be in the name of a sports person, and that gathered a lot of steam, and it reached the government. The government will do what is in its own interest. All the politicians will do what is in their interest, but they found that it is in their interest to change it. So something like that has to be generated, so that the government finds that it is incumbent on that, and it is in their interest to get into this.
Okay. Anyone else? We have reached 18:30 already. So our normal time for closure.
Can I get some time, sir, to speak?
हाँ भीमराव जी जल्दी
Yeah.
करिए.
Jaldi, sir. So protesting, sorry, I'm acknowledging, continuing this. Protesting means directly going to not on the roads. Protesting means just have at the ACC, let's take the ACC office building. Let us call some media channel people like all big TV9 or India Today, something. So they will take the interview and the debate. That is going to be, it is to be happen in the total India, a single day. So that is the protest by media, by papers, not going on the roads, standing on the roads like college students or something. It's not that way. It's wrongly predicted. It's not that way. Protesting in papers and via media. That's the electronic media. It will definitely impact on the government because the electronic media will go throughout India, throughout the world. So at least other world people also see. So the people get the shamed. So at least they will think about it. That's only my meaning of the protest. Thank you, sir. Namaskar. Dr. Kagal, are you there?
I think
Yes,
we
I am
have.
there. Shrikant Chanal, since your video and audio is coming through well, would you like to give the vote of thanks?
Okay, thank you, sir. My very thankful and very heartfelt, thanks to our Professor Mahesh Tandon. He agreed for to talk on this webinar series, and it was a very most what I can say, our heart vibrating kind of a thing that he has told what was there in our heart, and to tell few of the things what we were discussing about the question and answer. See, this architects on some of the TV channel, I was hearing about few months back, they are answering about the earthquake resistance buildings.
Yes.
So that was such a what can I say? I mean, very embarrassing situation for civil engineers, and that anchor was asking very frequently to the architect how to do this, and then asking for a very few structural engineers how to do that. Then some that geographical geology expert about this earthquakes and all that. This is such a funny thing that we were listening, and what Bhimrao has suggested to highlight and to start the TV channels and other media to expose our civil engineers. And we at the Bangalore Center, we are planning to do one radio program to highlight about what the civil engineers are and what the civil engineers are capable of, and how they are responsible for the buildings right from conceptual stage till the completion and maintenance. And we are going to start it very soon on actually it is in Kannada media. Once it starts on this thing, we will start off thinking it even to the TV channel at a later stage, depending on the success of our radio program. With this, parallelly, we are planning to have the technical articles on a very simple, as Professor Mahesh Tandonji has explained, on a very simple things, and with photographs that this for this particular thing, say foundation engineering, this civil engineers are structural foundation engineers, and this soil this thing is responsible. So like that, we are going to have a very generic and
Shrikant, your voice is breaking. Can you?
Simple way of explaining to the common people, so that they should at least start thinking that, oh, civil engineers are also there for the buildings. Because in my own experience, I think most of our ACCA members are aware. Okay. Yes, sir. Can you hear it now? Can you hear me now,
Yes,
sir?
yes. Yeah.
Yes.
Oh, sorry. Girish, you please complete it on my behalf. Can you hear me now, sir? Girish, please.
Yes.
Girish, please unmute yourself.
You have to unmute yourself, Girish.
Dr. Kargal, can you hear me?
Yes.
I'm sorry. The biggest challenge that normally I face whenever I had to summarize quickly what Professor Mahesh Tandon has said is that none of his points are fruitless. Every point is so very pertinent. But for the sake of brevity of time, I will try to cover as briefly as is possible. Professor Mahesh Tandon opened his talk acknowledging that we are indeed in troubled times. What with the engineers bill still at a standstill and architects amendment bill being predatory in nature instead of being collaborative and responsible. And therefore, we need to be very careful because the architects movement is more of a subservient in the profession. He referred to the historical civilizations to glorify and to establish the fact of how great the civil engineering profession has been, right since the Indus and Harappan civilization, which are almost 4,000, 5,000 years, that is about 2,600 years before the Christian era. He also went into the details of how the detailing of planning execution was done, which was then a Class B city building of 10 to 15 lakhs population. And he highlighted the Ellora, how it was built in the 6th and 11th century. And then he came to the Ajanta caves, where he described the frescoes. He considered masterpieces of Buddhist art. He also highlighted that how one Mr. Prasad Power had the passion to highlight and digitize the paintings, which meant that civil engineers have got a long way to discover their past, glorified past. Now, he also meandered to the bridges, wherein he drew a very interesting parallel to naturally grown bridges and took a specific case study of Northeast India, some Cherrapunji areas where banyan trees were grown. And then from there, he brought us back to the present day where the multi-tech bridges, as well as the multi-tech bridges already existed in ancient times about 500 years ago. Now, on the engineers bill, he took us on a brief journey on history where the Planning Commission set up the committee in 1966, which submitted the report under the aegis of Mr. Barve in 1970. He also called out the terms of study of the committee with the recommendations, two recommendations, one of which was to develop profession on healthy lines, avoid undesirable elements and practices, which we are now presently discussing, and have an all India institution or association on lines with similar association established by the Act of Parliament, such as the Chartered Accountants Institute. The second recommendation was the legislation to set up such an institution. He drew us to the present. He took us on a brief journey of the contributions of sterling civil engineers like the structural engineer Fazlur Khan, wherein he compared the Empire State Building of 1931 to the Chase Manhattan Building of 1961. One measure being the steel consumption, which was then 275 kgs per square meter, having dropped down to 145 kgs per square meter, using the concept of the truss tube design system. And he dwelt at length on that. And then the tall buildings, which are normally referred to as the mile-high buildings, 1,500 meters plus buildings. And he also took the example of the iconic American architect Frank Lloyd Wright's building, as well as Mr. Fazlur Khan's contribution to such high buildings. He also brought up the buildability challenges of tall buildings such as the Burj Al Arab in Dubai, wherein we had to go in for multi-stage concrete pumping because of the technical limitations of the concrete pump of 400 ATMs atmospheres not being exceeded. He also brought up the concept of or the risk associated and the solutions that we need to still find out with regard to fire risk. One such wishful concept being the parachuting of the people below, but then such concepts are there which civil engineers need to explore. He also dwelt on the vertical transportation limitations of not exceeding 10 meter per second because of the differential air pressure being there, which need to be addressed. And then also Mr. Eugene Truss's work, which he referred to as the 2-mile high Ultima Tower building, wherein literally a man can live cradle to cradle all through his life cycle without coming down to earth. He referred to the David Fisher's iconic concept building, wherein it is still in a concept where each floor rotates. And then we went on to refer to a lot of other iconic buildings drawing parallel to the Dancing Out building at Prague in Czechoslovakia, designed as per the bread and ginger concept. And then he went on to the skeleton of structural engineering, which is decided more by the structural engineer, wherein the other professions have no role except the structural engineer decides on the basic framework of a building once it exceeds a certain height. He came back to the need of our topic, which was the need for an engineer's bill, the accreditation process, the why and how an accreditation has to be done. And he did that in a very classical way as to why the accreditation is required and the challenges facing India. Basically, he took up challenges like, high vulnerability profile of the natural disasters. And then he went on to demonstrate as to how a natural disaster can strike India in terms of the tectonic plates. He took us on to the various plates that are there, which are pushing against one another, like the Laurentian and plates which get separated. And now the Tectonian plates getting met at the Himalayas. And then the differential speed, which is building up humongous pressure, which unfortunately has been now estimated to be housing 8.4 on the Richter scale, which can come out anytime. And therefore, he went on to the concept of the subduction, wherein he said that a small tremors now and then are much preferred rather than, conserving all that energy and letting it go in one boom and blast after 500 years. That is what he said. And then he again came back to the concept of the civil engineers bill, because the other challenge is the interlinking of rivers, which is a huge project by itself, running into thousands of crores of rupees. But then he said that the one recent start has been allocating 100 crore budget to come out with a DPR. He went on to tell us what is the interlinking, and that itself, I think, is a full day seminar. And then coming back to the concept of the engineers bill, he said that the commendable work has been done by engineers such as Engineer Sridharan. And before that, he went on to the concept of interlinking further by drawing on the history of interlinking of rivers, and then the cost of the interlinking, breaking down into peninsular, Himalayan, and the hydroelectric component, and ultimately the budget coming down to almost at an outgo of 15,000 crores per year across the next 35 years. Now, coming to the solutions, he said that ultimately, in conclusion, we should have an engineer's bill for two reasons. One is to address the challenges, both natural challenges such as the Himalayan earthquakes as an example, the interlinking of rivers, and also the other challenges, and also the man-made challenges like this superficial type of professionals who are trying to usurp our thing. And he said that if we don't do that now, very dramatically, he said that there's only one other solution, and that is to seek divine intervention. And therefore, with that, he concluded with a very humorous but a profound caricature of the apes, giving the high fives and the low fives, wherein we still languish on the engineer's bill 50 years hence. And therefore, in conclusion, he said that you have to do it now or you'll never do it again. So that was the conclusion. Thank you, Professor Mahesh Tandon. Back to you, Engineer Srikanth and Dr. Kalwal. Thank you.
Thank you, Girish. That was a good summation of the book. So without wasting much time, it's already 6:45. I thank all the attendees. Of course, we profusely thank Professor Mahesh Tandon. It's as usual, very lively and very useful. And every time you hear him, you learn 10 things more. So thank you, Professor Mahesh Tandon, for your kind gesture. And also thanks to all those who participated and, got benefit of listening to Professor Mahesh Tandon. Thank you, everybody. We'll meet next week, same time, for the next lecture.
Can
Sir,
I just thank?
Sir, I have only one last request to Professor Mahesh Tandon. to be present on the panel, last panel session that is going to come on 21st August. So that a fruitful outcome we are going to plan, and if he is there means it will be a great strength for us to take it forward. That is the only my request on behalf of Association of Consulting Civil Engineers, Bangalore Center.
I would definitely like to be there. The only thing is I have to just check up that there is no previous commitment, because Saturdays everybody thinks that Saturday is free. So today you will not believe that there are two things happening. There is this IS Tructees course on steel bridges which is happening, which I have excused myself because I am a panelist there, and there is the MORTH specifications are under revision. So they also meet only on Saturdays. So that also I have excused myself. I said that, you know, I made this commitment long before you fixed it to now only. But the Saturdays is very dangerous. But you people have selected also Saturday. So I will just have to check up whether it is possible to get out of that. But it is I think that I wish to thank Association of Consulting Civil Engineers for taking up this this issue itself. I think that itself is most commendable, and we have to get more and more people involved, even engineers who you never know. You know, somebody knows the minister, somebody knows somebody else. Like we got, I think this was what 3-4 years ago, we got the names of all the new parliamentarians who are engineers. I mean, this was obtained by one of us only. I mean, people who got that information, and we thought that we'll write to every one of them. I don't know whether it went further than that, but the idea that if so many engineers are there in the parliament, at least they should take interest and make sure that you know, at least the architect's bill doesn't come through or something like that. As a matter of fact, that's another suggestion I have, that it doesn't sneak through. If we tell at least our engineers who are in parliamentarians, and there is a list somewhere or the other roaming around, and we should write to them and tell them what these people are trying to do.
Sure, sir. You should, yeah.
Yes, sir. Yes, sir. We will take it, sir.
But anyway, thank you so much for inviting me, and I have thoroughly enjoyed preparing for this lecture. I myself have learned quite a lot of things which I did not know before, but it was a very good opportunity to do so. And I wish to thank the ACCE for that. And I hope that you have many such meaningful webinars instead of, you know, the regular kind of a thing where you meet and you have to go take a plane ticket and hotel and going and coming, which half the energy is finished there itself. This is so much simpler, and you can get a much wider participation. We've had people in, for example, in steel bridges, these course that is going on now, there are 300 people registrants where there are charges. I mean, from 7,000-8,000 rupees are the charges for that course per participant, and we got 300 participants. We could never imagine that such a thing would happen. We were thinking that maybe 70-80 people will come if we give it a lot of publicity. We were totally wrong. So this is a very good thing that you have done, and my congratulations, and I hope that there are many more things, such things will come. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, everybody.
Good night, sir.
Thank you, sir. Good night.
Good night.
Jai Hind.
Good night.